The atom is a basic unit of matter that consists of a dense central nucleus surrounded by a cloud of negatively charged electrons. In the center of an atom is a nucleus, which represents almost all of the atom's mass. The nucleus is made up of even smaller subatomic particles called protons and neutrons. The protons each carry a positive electrical charge. The neutrons are as heavy as the protons but carry no charge. This means that overall, the nucleus is positively charged, and orbiting around it are negatively charged particles called electrons. Electrons have a mass of only 1/2000th of that of a proton or neutron. The size of the negative charge carried by an electron, however, is equal to the positive charge carried by the proton. The electrons are moving at incredible speed, 3/4 the speed of light. So what stops them from shooting off in any direction? If we could pull an atom apart into its components, we would see that a neutrally charged atom has the same number of electrons as protons. It is this force of attraction or electrostatic force between the positive and negative charges that prevents the electrons from escaping. It's the number of protons that defines an element. A helium atom, represented by the symbol He in the periodic table, is written with two numbers, one above and one below. As part of this explanation, we'll split the atom into its component parts. On the symbol, the number 2 represents the proton number, the number of protons in the nucleus, also called the atomic number. In an atom such as this, which is electrically neutral, the number of electrons will be the same as the number of protons. The number above the symbol is the nucleon number. It's the total number of protons plus the total number of neutrons. The oxygen atom shown here has 8 protons in its nucleus and therefore must have 8 electrons. The nucleon number is 16. Since 8 of those are protons, the other 8 must be neutrons. Argon has 18 protons in its nucleus and therefore again 18 electrons. The nucleon number is 40. We know that there are 18 protons, and therefore there must be 22 neutrons. Larger atoms always have more neutrons than protons.